Welcome to this session about mocking outbound calls for easier testing. I'm Stefan, and with me I have Balázs, and we're going to talk about what's new in this release. When we build applications that rely on external services, we are often challenged with testing the integration code itself. If we connect to the actual service, we need to consider how that service will be impacted by us running tests. Will it impact production, perhaps? Is there rate limits? Is there other scenarios we need to think about if we actually hit the endpoint during our test runs? And how can we make sure that tests are isolated when we run them repeatedly? And how can we make sure that we maintain a consistent behavior on the external endpoint between test runs? If we then take in the external service and try to simulate it in our test environment, but outside BC, we are challenged with other scenarios, like changing the versions and changing the behavior and making sure things are aligned between the test code and the actual service that we are testing in our test environment. Even if we isolate the request to the external services and test the consumption of the results or the data that's produced for the service, there might still be scenarios where we cannot do that, where there's a dependency that talks to an external service, and we still want to handle that. To address many of these challenges, we have introduced a new test handler in this release, the HTTP client handler. And to teach us about how to use this test handler, I have Balázs to help us know and understand how to use this feature.
Thank you, Stefan. Well, in this demo, I'm going to walk you through how you can set up an HTTP client handler to test your outbound HTTP requests in your AL test. As an example, let's take a look at the document service. It has two methods, the get document content and the delete document, and both make an HTTP request to an external service. To verify that the get document content works as expected, we can create a test code unit and write a simple test method, like so. However, this setup requires that the external service is up and running. Instead, we can define an HTTP client handler to intercept the request and simulate a response for it. We can start by defining a procedure and adding the HTTP client handler attribute to it. Within the handler, we can simulate a response to a request by populating the properties of the response object. Finally, we can attach the handler to the test method using the handler function's attribute. When the test is run, the HTTP request will be intercepted and routed to the handler, which will mock the response. For the best coverage, we might want to test that our code can handle all kinds of different cases, not only successful ones. For example, error responses that we can simulate by setting the status code and the reason phrase accordingly. Unsuccessful requests, for example, due to a timeout, a DNS resolution, or some kind of network connectivity issue, and requests that got blocked by the environment. Keep in mind that when an HTTP client handler is attached to a test method, then all HTTP calls that occur during the execution of the test will be routed to the handler for processing. Therefore, if we were to, for example, invoke the delete document in the same test method, then both the get and the delete request would need to be handled by the same handler procedure. To know which request is being processed, we can analyze the properties of the request object. We can distinguish between the two by only looking at the request type property in this case. When the request is of type delete, we send the 501 not implemented response, while for the get request, we send the 200 success response. Great, but what if we are expecting multiple different requests with the same request type? Then we can use the path and query parameters of the request to know how to populate the response. It is important to mention that as of now, it is not possible to set cookies or redirection status codes. So far, so good. We can differentiate between requests and simulate the response accordingly. However, as some of you may know, it is possible to set the request URI by using a secret text. In that case, neither the path nor the query parameters are available, as the request URI must not be exposed. In that case, we can use the hasSecretURI property of the request to filter for this case. But then naturally comes the question, is there another way to handle this scenario other than throwing an exception? What if, let's say, the request is coming from a dependency that we do not want to mock? In general, is there a way to only mock certain requests while letting others make it to the external endpoint? The answer is yes. We have implemented a fall-through mechanism that allows the programmer to decide in the handler whether they want to mock the response for a request or issue the original one. Like so. In this case, when the request has a secret URI, then we just decide to issue the original request, as well as when the path is pointing to the /pictures endpoint. When the request is pointing to the /documents endpoint, we mock the response. This can be achieved via the Boolean return value of the handler procedure. We can use an exit true statement if we want to issue the original request. Conversely, we can use an exit false statement if we want the mocked response to be used. Keep in mind that the default return value is false. Therefore, a completely empty handler procedure would still block the outbound request and return a mocked response. Now, let's put it all together into one big procedure that is able to handle most of the previously defined cases. Just for fun, let's see how the mocking goes in action in a debug session.
Let's publish the app and start the debug session. Then, we can load and run the document service tests. The getDocumentContent test is run first. It invokes the getDocumentContent method with a dummy document ID, which makes a GET request to the localhost /documents endpoint. The request is then intercepted by the handler. We can look at the properties of the request object and confirm that it is indeed the GET request coming from the getDocumentContent. Then, the handler extracts the document ID from the query parameters and fabricates an example content. Finally, it populates the status code and reason phrase to simulate a successful request and uses an exit false statement to make sure that the mocked response is used. Stepping back into the getDocumentContent method, we can analyze the response object and confirm that it contains the mocked values, including the content that needs to be extracted first. The content check passes and the test successfully completes. The delete document test is run afterwards. It invokes the delete document method with a dummy document ID, which makes a delete request to the localhost /documents endpoint. The request is intercepted by the handler, and we can verify the request by looking at the properties, just like before. As the request is of type delete, the handler simulates a 501 not implemented response and returns with an exit false statement. As the response object received by the delete document method does not have a success status code, it signals an unsuccessful delete operation by returning false. Therefore, the test fails with a document deletion failed error.
Finally, I'd like to draw your attention to this new property that we have introduced called Test HTTP Request Policy. You can add it to test code units to specify how outbound requests should be treated during test executions. By default, all requests are allowed, but you can further restrict this to only allow ones issued from a handler or to block all unhandled requests. The following table shows an overview of all of the scenarios. We can see the different handler setups on the left, while the property values at the top and the outcome for all of these scenarios in the middle. Let's take a look at all of them in a bit more detail. When the property is set to allow all outbound requests, which is also the default value, then no restrictions are imposed on outbound requests. To illustrate the three main scenarios, we can take a look at the example on the right. It has three test methods, one with no handler, one with a handler that issues the original request using an exit true statement, and one with a handler that mocks a response. In this case, all three are allowed. When the property is set to allow outbound from handler, then only those outbound requests are allowed that are first intercepted by an HTTP client handler and then issued to the external endpoint by a handler fall-through using an exit true statement. This is to ensure that no unintentional requests are made. If we look at the same test setup, we can see that the first test that has no handler it's blocked as it tries to make a call directly to the external endpoint, while the one where the handler issues the original request is allowed. When the property is set to block outbound requests, then all outbound requests must be intercepted and handled by an HTTP client handler. This can be very useful if you don't want frequent test executions in your automated CI/CD pipelines to hit the actual endpoint. In the example, we can see that the first two methods that try to make a call to the external endpoint are blocked, and only the one that simulates a response is allowed. That's been it from me.
Thank you very much for your attention.